Assalamu alaikum, dear students. Today we will discuss composite functions. Exercise 5C, question number 1. For each of the following pairs of the functions, find f of gx and g of fx. We do the last two parts for better understanding. In this part, h, fx equal to x square and gx equal to 1 plus 2x by x minus 1. To find out f of gx equal to f of 1 plus 2x by x minus 1. It is equal to 1 plus 2x by x minus 1 whole square. Why? Because fx is given as x square. This is how we have found f of gx. Now we solve for g of fx. G of fx equal to g at x square. As fx is given x square, g of x square is equal to 1 plus 2x square by x square minus 1. We have substituted x square in place of x in the gx to find out g of fx. In this part, fx equal to 5 minus 2x and gx equal to x plus 2 by x minus 1. Now to find out f of gx, over here we have substituted x plus 2 by x minus 1 in place of x in fx. Now we solve it. Opening the bracket, 2 is multiplied by each and every term in the numerator. X minus 1 is LCM of denominators. On solving it, it results 3x minus 9 by x minus 1. Taking 3 common, it results 3 into x minus 3 by x minus 1. Now we work out for g of fx. Now to find out g of fx, g at 5 minus 2x. It results 7 minus 2x by 4 minus 2x. So g of fx equal to 7 minus 2x by 2 into 2 minus x. Now the statement of question number 3. If fx equal to 2x square plus 3 and gx equal to 2x plus 1, find number 1 the composite functions f of gx and g of fx. Part 2. The values of f at g minus 1, g at f minus 1, f at g3 and g at f3. Now we solve it. These are the functions given to us in this question. Now part 1, f at gx. Now we solve it. Opening the bracket using identity. After further simplification, it will be 8x square plus 8x plus 5. So f of gx is equal to 8x square plus 8x plus 5. Now we find out g of fx. To find out g of fx, now we'll open the bracket. This 2 will be multiplied by each and every inner term. So g of fx equal to 4x square plus 7. Now we find out f of g at 1, g at minus 1. F of g at minus 1, substituting minus 1 in place of x in f of gx, this results 5. Now g of f at minus 1, it results 11. Now we find out f of g at 3. After putting the values, solve it. F of g at 3 equal to 101. Now we find out g of f at 3. G of f at 3 results 43. Now the statement of question number 4. If fx equal to ax plus b, where a and b are constants, g at x equal to x plus 7, f at g1 equal to 7, and f of g at 2 equal to 15. Find g of f at 5. Number 2, solve the equation g of fx equal to 14. Now we solve it. These are two functions, fx equal to ax plus b and gx equal to x plus 7. First we find out f of gx. So f of gx equal to ax plus 7a plus b. F at g1 is given 7. It becomes 8a plus b. This way, first equation we have developed 8a plus b equal to, it is given that f of g at 2 equal to 15. With the help of it, we will develop second equation. F of g at 2 we have calculated 9a plus b, and it is given that this is equal to 15. Now we have developed the second equation this way. Now we will solve them simultaneously to find out the values of a and b. Subtracting one equation from the other one, a equal to 8. Now putting this value of a in equation number 1. This way, putting in equation number 1, we will find out the value of b. b have find we have find out the value of b, which is minus 57. After using the values of a and b, fx is equal to 8x minus 57. Now in part 1, g of fx is equal to g of 8x minus 57 equal to 8x minus 50. Now g of f at 5 is equal to minus 10. We have to solve the equation when g of fx is equal to 14. Now we will solve this equation to find out the value of x. We have got x equal to 8. Statement of question number 5 is, functions f and g are defined by fx equal to kx minus 3, where k is a constant, and gx equal to 2x plus 5. Find the n expression for f at gx. Number 2, the value of k for which gx at x f gx is equal to gfx. Here two functions fx and gx are given. We have to find out in part 1 f at gx. Solving this stuff, f of gx is equal to 2kx plus 5k minus 3. We have to find out the value of k when f of gx is equal to g of fx. F of gx we have found in the previous part. Now we will do g of fx here. 5k equal to 2 and k equal to 2 by 5. Statement of question number 6. Given that fx equal to 2 by x and gx equal to 3x minus 4, find f of gx and g of fx. Number 2, show that there are no real values of x for which f of gx is equal to g of fx. These are two functions given here. First we find out f of gx. We have found f of gx equal to 2 by 3x minus 4. Now g of fx, is, now solve it, g of fx equal to 6 by x minus 4. Now in second part, f of gx is equal to g of fx. Now we solve this equation, multiplying both the sides by LCM of denominators. Now we simplify it. We have simplified it. Now dividing both the sides by minus 4. It is the quadratic equation we have developed after simplification. Now we solve it for the value of x. No midterm split possible here. So using the quadratic formula for its solution. Now solving it. As in the final result, we have a minus value in the under the radical sign. So this results into an imaginary value. So no real solution possible here when f of gx is equal to g of fx in this question. All the best. See you in the next lesson. Bye.